Hey guys, welcome back again to another edition of Algebra 2. Mr. Anderson here, your fearless leader, leading you into section 6.4. We're talking about nth roots today. Remember, we've talked about square roots before, and then these are just going to be all the other roots where you have the third root and the fourth root and so forth. So just goes a little more detail on those things. All right, let's take a look at our objectives today. First of all, we want to be able to simplify radicals. And then secondly, use a calculator to approximate radicals. That's all we're doing today. All right, so let's take a look. First of all, kind of remember back when we were talking about square roots. And I've got this in the first thing here. Uh-oh, let me see. I got to get my pointer going. All right, so in our first example here, remember if we had 9 squared, that was 81. Well, to undo that, remember we took the square root of 81 would get you back to 9. So squaring something and taking the square root of it were opposites of each other. Well, it's going to work the same way for other powers as well. Here we have 4 to the third power, which gives me 64. Well, if I take the third root, notice the little 3 up here, the third root of 64, it gets me back to 4. And you can see that it works in the other cases here. The 5 to the fourth power is 625. The fourth root of 625 gets you back to 5. And you can see that with 2 to the fifth power is 32. The fifth power of 32 is back to 2. So you can see in all these cases, putting something to the third power, the opposite of that is taking the third root. And fourth power, the opposite of that is taking the fourth root, and so on and so forth. Okay? That's not too bad, right? All right, let's take a look at this. This is just kind of some terminology and things here, and then we'll actually get to simplifying a few things. Okay, so first of all, the little number up here, that's called the index. It's good to know that. The index, that's where if there's nothing there, it counts as a 2, okay? That's the square root. So most of the time when we have like an x, if there's nothing written in front of it, it counts as a 1. Well, in this case, if we have a square root and there's nothing written here for the index, it counts as a 2. So it's a little bit different there. That's a 2 if there's nothing written there. Of course, the radical sign, you know, we're familiar with that. And then this number under the radical sign is called the radicand. Okay, so just some terminology there to be aware of. And then the other thing here that you should kind of know a little bit about is if my pointer seems a little sticky here suddenly. If we're taking the square root, say of 25 in this case, and that equals 5, well, that's our principal square root. Technically, if we have the square root of 25, couldn't that also equal negative 5? Couldn't negative 5 times negative 5 also equal 25? Yes. So that's why they kind of distinguish some of these things here. So when they ask you for just the square root of 25 like this, they mean they want the principal square root, which is the positive. If they want the negative square root, or sometimes the opposite of the principal square root, they might say, they'll put this negative sign out in front. So if they write it like this, that means your answer will be given as negative 5. That's where you give the negative root. And if the plus minus sign here, if you have that out in front of your square root, then they're looking for both of those roots. Okay, so just some terminology to know when they're looking for the principal square root, the negative, and then both of them. Okay? All right, so let's look at a few things here. Now, you notice in the first case, it's plus and minus. So our answer, we're going to give both the plus and the minus. All right, so we're going to have plus or minus, and basically kind of break this down. Well, we got the square root of 16 here. Now, you don't have to write this all out when you do these. You can do a lot of these in your head, but I'm doing this to show you how to follow through on this. And then you've actually got the square root of x to the 8th. Okay, well, the square root of 16 part's easy. That's just going to be 4, right? So square root of 16 is 4. We got the plus or minus and 4. Okay, what do we do with this? Well, remember I told you before, if you had the square root, it canceled out a square. Third root cancels out a third power and so forth. Well, these don't match. I've got a square root. This counts as a 2 here, and this is an 8. What can I do? Two ways you can look at this. First thing that you can do is you can think of this as break this down into go, well, what could I do to write this x where I'm going to have x something raised to the second power? So I'm going to have here a parentheses. If I get it something raised to the second power, then that second power could cancel out that square root. Well, what would that be if it's x to the 8th? It would be x to the 4th raised to the second power. Then the square root could cancel the second power and leave us with x to the 4th. Okay? So 4x. So plus or minus 4x to the 4th. That's not too bad, right? The other way that you can look at it that is maybe even a little easier than that, remember this is like a 2 out here, right? The other way that you could do this to get this 4 here, and it should work every time, take the number under here, the 8, just do 8 divided by 2. What's 8 divided by 2? 4. So that's another way that you can look at it. If that helps you, just take the number, the power that's raised here, and divide it by the number that's in your index there. And you could just divide those out. In this case, you get a 4. Okay? All right, second one here, we've got a negative out front. So our answer is going to be a negative. Now, okay, you see this parentheses here. Don't get all freaked out like, oh, the parentheses, I got to take y to the 3rd to the 4th power and 5 to the 4th power. And, okay, don't do that. Really pretty simple. Remember how this was x to the 8th here that we did? And we could get, kind of deal with these exponents here. We can do the same thing when it's on a parentheses. You just treat this whole parentheses like it's an x. Okay? So remember what we did before? I'm going to do this, what I think is a little bit easier here. We did 8 divided by 2 here, right? Well, let's look at this one here. We have a 4. This is also a 2. So we can just do 4 divided by 2 is 2. And so that means my answer here is going to be exactly what's in the parentheses, y to the 3rd plus 5. But then since we did 4 divided by 2, it's going to be raised to the 2nd power. That's it. That's our answer. It's not bad, right? Okay. These are looking a little friendlier now, aren't they? All right, this one. Ooh, this one looks scary. It's not that bad. Again, let's just kind of break it down. Now, first of all, I have a feeling, I haven't actually punched this into my calculator yet, but I have a feeling that this one's going to work out evenly here. And so we're going to take here, we've got the 5th root of 243. And so you can punch that in there. You just remember all these stuff with the roots here. Oh, I wonder if I can get up my calculator. I don't know if I can do that at this point. Let me see. I don't think I can. I don't think I can get out of this and stop recording to get my calculator up. I'll go over it in class with you, but basically just hit your math button, and then you go down to, it should be, or actually, sorry, escape out of that. You'd type in first, if we're going to do the 5th root here, type in 5, then hit your math button, go down to its number 5, because that's what gives you where you can put the little number in here. Enter, and then type in your 243. And in this case, this works out to be, sorry. This works out to be 3. So the 5th root of 243 works out to be 3. Okay, pretty good. And then just with these other ones here, just divide like we did before. So a to the 10th, just do 10 divided by 5, which is a squared. And 15 divided by 5, which is b to the 3rd. And that would be our answer there. All right, last one on this page here. Now, this should look a little familiar to you. Now, notice we've got not the negative out front, we've got a negative inside. Well, that's when we get imaginary numbers. Remember that? So, same thing's going to hold true here. So we've got, first of all, the square root of negative 16. And which you remember from what we did before, this is going to be what? The negative becomes, the square root of negative 1 becomes I, and then the square root of 16 is 4. So this is going to be 4I for this part. And then the rest will work the same way as before. The x to the fourth, and then we're going to do 4 divided by 2 is x squared. And then 8 divided by 2 is y to the fourth. So if you get a negative under the square root, all the stuff kind of works the same way, but just remember, if you have a negative in there, it's going to cause you to have an I. Okay? All right, next thing. We're going to have, there is one time when you simplify, you're going to need to use absolute value. And I'll kind of try to walk you through the steps of how that works and show you when to look for this. Well, let's start with this one here. Square root of 5 squared. Well, you go, oh, well, the square root cancels the square, and that just is 5, right? And when these cancel, you go, oh, that makes sense. What if I walked through this like the whole way, where I did 5 squared is 25, and then I took the square root of 25, which is 5. I get the same thing both ways, whether this cancels or whether I kind of walk through the whole problem, do 5 squared to make it 25 and then take the square root. I get the same thing both ways, right? What happens on this one? If I just cancel these, the square root cancels the square, and you go, oh, I get negative 5. But what if I walk through the whole problem and I did negative 5 squared is positive 25, and then I take the square root of 25, I get positive 5. Oh, wait a minute, I got two different answers. This way I got negative 5, this way I got positive 5. So here's where the problem comes in. The positive 5 is correct. Okay, doing this the long way, when we actually go through the whole steps of working this out, we get a positive 5. That's what we're supposed to get. Okay, it's just that on this first kind, no big deal. We got the same thing both ways. On this one, we didn't get the same thing. This is correct. So here's what you have to look out for. If you can remember this, even, odd. If you can remember those words, even, odd. Okay, even, odd. What that means is, when you're going to simplify something here, if the index out here is even, in this case it was 2, and your power inside here is even, in this case 2, and then at the very end you end up with an odd power, like here it's 1, that you're going to have to make this an absolute, your answer is going to be the absolute value of whatever you end up with. So in this case it didn't really matter. You know, we had even, odd, so this is like 2, 2, and 1, right? There's like a 1 here, since it's not written. Our final answer has to be positive. Okay, it already was positive, so that was fine, but on this one, even, odd, again, it didn't give me a negative there. I have to make that positive by taking the absolute value of that to make it positive in the end. So there are these times when you have an even index, an even power, and then an odd power at the end, that you have the possibility of this being negative, and so you have to make it positive. It could be positive like it was here, and no problem. But here, if it's negative, it would have to be positive. So in this case, we can tell because it's numbers. Most of the time, it's variables, and so we don't know if it's even or odd. So we put the absolute values around our exponents. Okay. So let's look at this first one here. Even index, even. When these cancel out, what happens? We have just x to the first, which is odd, right? So we had it 2, 2, and 1. That's even, even, odd. What's left is x. Now we don't know if x is positive or negative. It could be negative, but we don't want it to be negative. This is supposed to be positive, so our answer is going to be the absolute value of x. Okay, when we write our answer there, we have to write absolute value of x. Okay, in this case, it was just like the 5 up here. X could be 5 or negative 5, but we don't want it to be negative 5 in our final answer. If it was negative 5 in here, it needs to be positive 5 out here in the end. So we have to put absolute values. All right, let's look at this one. Even, 6, even, 6. So that's even, even. When these cancel, the 6th root cancels the 6th power. What do we have left? T. That's odd. T to the 1st power, so this would need to be absolute values. Okay, so anytime that happens, you have to put whatever that happens to in absolute values. Now, the last one here, square root of 36, we don't have to worry about that. Square root of 36 is just 6. We know that. And by the way, if you look at that closely, when we break down the square root of 36, what is that really? It's square root of 36 to the 1st power, right? So it's even, odd, and then odd. So that's why it didn't matter there, because it wasn't the even, even, odd pattern. So 6 is fine, but then 6 divided by 2 is y to the 3rd, but we had even, even, odd, so the y to the 3rd has to be put in absolute values there. Okay? So just, kind of watch out for that. And let me just briefly show you why it has to be that even, even, odd. What if you had like the 3rd root of negative 2 to the 3rd power? Well, if you just canceled out the 3rd root and the 3rd power, what would you get? Negative 2. And you might think, oh, wait a minute, I got a negative just like I did over here. But wait a minute. What if you work this out fully? Negative 2 to the 3rd power is negative 2 times negative 2, positive 4. 4 times the negative 2 is negative 8. So what you really have is the cubed root of negative 8. And if you punch that in, let's see, 3rd root, I'm going to get negative 2, the same exact answer. So a couple of things to remember from this. Number one is if you have an odd and an odd instead of even, even here, that's fine. Even if you get a negative number here, you're supposed to get a negative number. Here you had to get positive. So here with the odds, it doesn't matter. The other thing is, notice, as part of my example here, when we took the 3rd root of negative 8, it equaled a negative 2. So we're used to seeing square roots always come out to be positive. But if you have 3rd roots, they don't necessarily have to come out to be positive. So that's another thing there. Okay? I don't know if there's anything else I was going to talk to you about there, but that's the main thing with the even, even, odd that you need to remember on that, okay? All right, last thing. Is we talked about using a calculator to approximate the value to 3 decimal places. And so again, all we're going to do here is just punch these into our calculator. And so, first we've got one. This shouldn't be that hard. Square root of 58, just, hit your square root button. 58, enter. And what I get here is 7.615773 and so forth. But it says round it to 3 decimal places. So what are we going to do? We're going to go 1, 2, 3 decimal places. We're going to cut it off right there, which means the decimal place right past it is a 7, so that means this is going to round up, and it's going to be 7.616. Okay, remember how we round those. And then again here with the 5th root, just remember, again, how we do this. Type in on your calculator, type in the 5, and then you hit, then you're going to hit your math button. So I'm going to go 5, hit the math button, and then I'm going to go down to the symbol that looks like this, the x with the square root, because the 5 that I typed in, that's what goes in the x here, so that's our 5th root. And then you can type in the negative 43. Enter. And here's what I get. Negative 2.121747 and so forth. And again, we're going to round this to 3 decimal places. It means we're going to cut it off right there. And so our final answer there is going to be a negative 2.122, because this 7 again rounds that up to a 2. Okay, so that part shouldn't have been too hard. It's just typing stuff in your calculator. All right, that's it. That's our stuff with radicals. Thanks for joining me, and we'll see you next time in section 6.5. Bye.